or and then we'll have a short Q&A session towards the end. Okay. We'll dive into the introduction and basically what application security is. It's basically the art of it's like an art. Everything is an art. So application security is the art of securing applications. By applications, I mean mobile applications, web applications, and APIs. So
We've lost you.
hello, hello,
Now you're
hello.
back.
Yes,
Yeah.
now I'm back. Pardon the internet. So this is done to ensure the reason why we do application security is basically to ensure that our applications are secure. The applications that users tend to use. So you ensure that their data is confidential and just ensuring that the data that they're preserving the integrity of your application and ensuring that your service is always available. So one of the big differences between application security and DevSecOps is application security is focused on the development part of the development and the deployment part of the application, while DevSecOps takes a holistic approach to in the software development lifecycle. So this is why you look at now your threat modeling comes in, your things like infrastructures, code, and secrets management and hardening of stuff like Kubernetes and Docker, which I think is not the scope of this conversation. So I think I'll stop on DevSecOps at this point. And also, DevSecOps tends to take DevSecOps also is also very more collaborative as just compared to application security, because as you will learn in future, which I believe that you will, is DevSecOps also includes operations, and operations is not just a small thing. Operations also includes the business functions and whatnot. So DevSecOps is very, very huge, and application security is just a small part of DevSecOps. I wouldn't want to say the percentage because I don't want to be quoted incorrectly out there, but application security is a very, very small part of DevSecOps. Okay, and then now that we've gotten that out of the way, we'll look at common vulnerabilities uh, facing different applications. So this at this point, I think I'll take you through the OWASP top 10 for every for web applications, for mobile applications, and for APIs. So basically, OWASP Top 10 is a compilation of an organization known as OWASP. So OWASP has been there for the longest time possible, and their aim is to ensure that applications, they just come up with different rules and standards that define security of applications. So every once in a while, OWASP compiles a list of uh, of different vulnerabilities and different threats that face web applications, mobile applications, and the APIs. So this has become to this has got this is known as these are known as the OWASP top tens of those different categories. And this these are usually updated and maintained by researchers from different parts of the world. So they also they have leaders, yes, but they have it's you can always go to their GitHub repository and contribute to the different lists and the different projects that they have. Some of the projects they have are uh, things like the OWASP Juice Shop. I think they maintain I've forgotten the one that they maintain for APIs. It's just escaped my mind at this point in time. But they also have other standards for building for testing web applications, for testing mobile applications. They have a standard for building an application security program for people who want to do that. Yeah, there are very many things that you can, OWASP has very many projects that you can look at. But at this point, we'll go through the OWASP top 10 for web applications and for mobile applications and for APIs. Okay, so I'll start with web applications. So the last release that was done was in 2021. So so I'll take you through what was on the 2021 list. So at first, the first one you had was broken access control. So what's what is meant by uh, what is meant by broken access control is basically ability for users to escalate their privileges and have access to pages that people and users people can have access to pages that they're not supposed to have access to, and ability to bypass different access controls by modifying maybe the URL or the HTML page so that you're able to get access. So this is a good example of this is let's take for example an e-commerce platform. So this e-commerce platform that we have in mind is an e-commerce platform where a user like you and I can be able to can be able to buy can be able to buy your favorite commodity, but then you're not able to say that a stock that an item is over, or put an item on offer, or create discount codes, because those are things that should be done by the e-commerce platform administrator, for lack of a better uh, name to name this particular actor. So you have you have your so now you find that it's possible for you to maybe create a discount code, which is not supposed to be a functionality that you're supposed to access, but you're able to access it. So that is a case of broken access control. And then the next one is cryptographic failures. So cryptographic failures comes from cases like it comes from the word cryptography, which is basically to hide something. So as we all know that one of the one of the one of the security features that someone needs to put on an application is to ensure that data is encrypted in transit. So these are things like this is SSL and TLS. So one of the failures that can be there is things like uh, the the data being transmitted through clear text. So this makes it possible for someone to be able to do man in the middle attack by just someone not man in the middle attack by this makes it possible for someone to sniff traffic, and they can be able to see what exactly is happening. I believe people who've done the cloud and network security track, you guys have done a chapter on Wireshark, and you're able to look at to capture traffic being transmitted, and you're able to see if the traffic is being transmitted over HTTP, able to see the traffic able to see what exactly was being sent on that particular network at that given time. So that's one of the examples of cryptographic failures. And then there are cases where uh, generation of keys that uh, crypto keys that are weak, and or the things there is no proper key management or rotations, and cases of putting cryptographic keys, so your SSH keys in version control, and making these repositories public and available for everyone. And then there are also cases of where you have SSL, but your certificate is not uh, is not validated. So these are self-signed certificates that are not gotten from a certificate authority that you can that are not well put. And there are many other instances of there are also things like weak hashes, using hashes like MD5 or SHA-1, which can be easily broken and have been broken severally in the past. And then was top 10 for web in 2021. They merged they merged what did they merge? They merged. Oh no, it was always there. Injection. So injection is just a combination of uh of your SQL injection, your HTML injections, and so on and so forth. So this basically allows people to enter data on forms that are not sanitized and are not validated, and or they're not filtered by the application. So in cases where you want to do a cross-site scripting attack, you do your open tag script and then your payload, and then close your script tag, and then you're able to get something. You know how you guys have done. I believe that you people have done CTFs. So I don't think that is something that we need to really explain deeply. But yes, so that's one of the forms of injection attacks. Another one are SQL injection. So this is basically putting SQL statements on as user supplied data, and then you're able to perform SQL functions from your UI. Uh, yes, so those are some of the examples of injection attacks. And then the next one is insecure design. So insecure design is insecure design is just things related to flaws that are made with the assumption of at the design stage. So not really looking at the big picture, or missing a little bit of controls that need to be put on the application. So this is basically insecure design. It's not a code issue really. It's more of an issue in the design stage. These are flaws that come because you haven't really thought through about on how your application should work. And then security misconfigurations are are security misconfigurations are things that huh, sorry, security misconfigurations are happen take place if they're missing missing security hardening measures on your application. And then when you have unnecessary features that are enabled. So when you're enabling ports that you don't use, so maybe you have ports 3000 open and you don't use ports 3000, and then you have a service that's not being used, that is unnecessarily exposed. And then also security misconfigurations come when maybe you haven't handled your privileges very well, and so many other cases where your you might have security misconfigurations on your application. So the other five are use of vulnerable and outdated components. So this is basically using packages that maybe are no longer being maintained, or packages that have been found to have vulnerabilities and you haven't updated them. So those are some of the instances where you have vulnerable and outdated components. And then identification and authentication failures. So identification and authentication failures usually take place when you have when you have a flaw in your authentication process. So a good one that I've seen is one that I've seen in the field quite a lot, and it really bothers me why we still have it in the field, is where you have you have an application that's running. It has a login page where people log in, and then when you have OTP, you're taken to a page where you get an OTP on your mobile phone, and then you enter the OTP. So most of the cases you find that it's possible for you to brute force this particular OTP, because uh, from what I have seen and what I have understood is mostly a good number of Kenyan companies companies, or rather East African based companies, for luck, yeah, to just give you the picture of how big this issue is you're able to just stuff, and because it's just 4 digits, so it can be 000 and up to 9999. So you do a list, and then you send you send all those you send 10,000 requests to that particular server. So you'll always get you'll always get the right combination, because there's very many things that are not done. There are things that could be done better. So that's one of the examples of an authentication failure. And then software and data integrity failure. So these are cases where you get you find that your application is very trusting in some cases. So you're able to you're able to uh, but sometimes you don't verify maybe signatures from from one from one service to another, if you're using a certificate to authenticate those two particular services. And then you also have cases where you you have your packages and your components and your libraries running on that particular application, but you don't know where this library is from. So for people who have watched, there's an interview I was listening to of Pavel Durov. Pavel Durov is the founder of Telegram, and Piers Morgan. So he was telling Piers Morgan about how his words, so that I don't get, you can go listen to more of his story, but he talks about how the American authorities wanted to compromise Telegram, so they got a developer and they wanted to ask them what packages they use, so that they're able to to write malicious code that when this applications are being when Telegram is being run, able to have a quote unquote a loophole on the application, so that they're able to see what exactly is being shared. Yeah, it's a very interesting interview. You can go listen to the rest of it on YouTube. So those are some of the examples of data integrity failures. So if people don't verify if these packages come from the right vendor, you're likely to have maybe malware running in form of a malicious package. And then security monitoring and logging failures. So this is basically not being able to monitor what exactly is happening on your application. So if you can't protect your application from something that you can't see. So the moment you have your eyes, you're able to see more, and you're able to also come up with proactive measures. And then that's basically server monitoring logging failures. And then you have your server side request forgery, where you have the ability of your application sending requests to another application uh, through maybe an API or an so you're able to get more information from you about an basically allows an attacker to
Hello, Kiiru.
that you have set up, because they're able to yes.
I
Hello.
don't know if it's on my side, but you're breaking.
Hello.
Hello.
Oh, I'm breaking. Anyone else who thinks I'm breaking?
On my side too.
Yes, you are slightly.
Yes, you are breaking.
Okay.
Check your internet
Okay,
connection,
let me
please.
let me just look at it shortly. Meanwhile, are there any questions so far? Okay, so
There's a hand. There's a hand from Alan. Is that a question? Okay, it's gone down. So, any questions so far?
Okay.
Mhm. Okay, Alex, go ahead. Hello, Alex.
Okay, thank you. I hope you can hear me. Hello.
Yes, I can.
Yes, yes.
Okay, thank you. My question
Hello.
was my question was sometimes you log in on a site and it give you an authentication key. So when you try to log in again, it accepts. But when you log out and try to log in again, it says that maybe the password or the login that you are putting in, it is not right, but it is right. So how do you categorize it on our OWASP top 10? Under which part does it belong?
Just a minute. I think Kiiru dropped off. Okay, he's back.
Hello.
Hello, Kiiru. Hello.
Yes.
Did you hear the question?
No, I didn't hear the question. Please come again.
Okay, thank you. My question was, at sometimes log in on a site, then it give you, let's say you are registering on a site, it give you an authentication key. Then when you log in, it accepts that you have logged in, and when you try to you log out, then you log in again, you give it the authentication key or the password, then it says that the password is wrong or the authentication is wrong. But in real sense, the password that you are giving in is right. Then it requires you again to reset the password. Then it send you the authentication key via the email. Then you log in. When you
Hello.
Alex, you're also breaking. Hello. So, but I think the gist of the question was logging in via OTP, and then once you try logging in again with the same OTP, you're not allowed access.
yes.
Alex, uh-huh.
Ah,
So is that a security issue per se?
no, it's really not a security issue. It's usually a user issue or an application issue, which is basically a bug. So yeah, it's not really a user issue per se, because once you have the OTP, because the OTP is usually stored on a database, so if that OTP is correct or it hasn't changed, the OTP should work.
What if it's a security control that you can just use that OTP one?
Yes, you can also, ideally, you should use an OTP once. You shouldn't use an OTP multiple times. So when you log in, your OTP should be invalidated, and then you need to request for a new OTP. But you find in some cases where you can have the same, if you have the same site opened twice and you use that OTP, and someone else uses the same OTP, if you guys had opened the site at the same time, or rather you send the OTP at the same time, the two of you might have the same OTP, which brings a vulnerability called a risk condition. Yeah, so I think once I start discussing risk conditions, the conversation will go beyond the scope, but I hope I have answered your question.
Alex,
Hello?
was your question answered?
Yes, my question is answered, but no, my question was okay. You have been given the OTP. You will have to change the password. And then after changing the password, when you log out and try to log in again, it says that the password is wrong. and in real case the password is right. Or
Then
what could be, yes.
in cases like that, maybe it's usually a development flow, when it's usually a development issue, because when you ideally when you change your password, the password should also change. What's the hash that was stored in the database should also change. So it's usually an application issue and not really it's not really a security issue, but a development issue.
Okay, thank you.
Welcome. Okay, so I believe that I'm clear now, and if I'm breaking, you can let me know. So, but then I'll continue to the OWASP top 10 for APIs. So, so this was released in 2023. So this has
Just,
Are you sharing your screen?
yeah.
oh sorry, I call dropped. I forgot to share the screen. Can you see my screen now?
Yes,
Hello.
we can.
Okay.
Yes.
Good.
Yes.
So you have this was the OWASP top 10 for APIs was released in 2023. The last one was released in 2023. That was last year, and so you have broken the first vulnerability on the list is broken object level authorization. So I tend to confuse this a lot between I tend to confuse what is I like calling it Bola and the third one Bopla. So broken object level authorization is basically having API is basically exposing endpoints that have just a moment. So yeah, so basically the broken object level authorization allows different this is really an issue affecting endpoints that allows application that allows that allows an API to expose data that is not supposed to be seen by an attacker. So you can have an endpoint, let's say, showing revenue data. So you're able to see a list of all shop names back to our e-commerce application. So you're able to see a list of all shop names or rather maybe shop IDs. So you're able to look through this particular shop IDs. So you have shop ID number 1, shop ID number 2. So you can find, let's say I run a shop on that particular e-commerce application and it has a shop ID number 45. So if I want to see my revenue stream, my revenue charts, my revenue data, I go to revenue data /45. So if I change the ID on the URL to 46, maybe I'm able to see someone else's, I'm able to see revenue about the revenue chart of someone else's shop. So that's an example of broken level authorization. And then broken authentication is just like I explained on the OWASP list for web. So just having flaws on your authentication flow. So you have you can the same example for the OTP where you're able to do a list of OTPs from 000 to 9999 applies here. And then broken objects property level authorization. This was this was this was this was this was this is a merge of two vulnerabilities on the OWASP top 10 for APIs in 2019. There used to be a vulnerability called excessive data exposure or information disclosure, and then you had another one called mass assignment. So what happens in excessive data exposure is maybe you have an endpoint that's supposed to give you my name and my age, but this particular endpoint will give you your name, my age, my phone number, my next of kin, my KRA pin, my ID number, and so on and so forth. So that's more data that is being exposed as compared to what exactly the end user requires. So yeah, that was excessive data exposure. And then we had mass assignment. So mass assignment basically allows a user to add more parameters or more parameters on their API endpoint if the API endpoint is sending information to an application server. So let's say you have a sign up page that you have your name, your email address, your phone number, and the password. So you might have this particular this four parameters on your API endpoint, but in some cases you might find that it's possible to maybe add a Boolean value of, let's say, is admin, which is true. So that way, when you sign up the application, if you add that particular parameter, you become able to sign up as an admin if you're a customer. So that's the other part of broken object property level authorization. And then unrestricted resource consumption is basically having an API endpoint uh, send or receive make so many requests to a server. So this basically brings about cases of maybe resource starvation on the instance, or your resource starvation on your application server, or if you're using metered services, you have cases of your costs going up. And that's why I think you guys have seen those AWS jokes on the internet where someone left something running and they have a bill of, let's say, $10,000 or etc. So if you send many requests, so this many requests uh, equals to more resources to process these requests. Yes, and then broken functional level authorization. This is basically exploiting an API with the aim of uh, getting getting access, or getting the ability to see services on endpoints that you're not supposed to use. So let's say back to our e-commerce application. Uh, if you have an endpoint that's supposed to show me all my customers, me as the shop owner, I should be able to interact with that endpoint, but my customer should not be able to interact with that endpoint. So if my customer is able to interact with that API endpoint, then that becomes a case of broken functional level authorization. And then next on my list is unrestricted access to sensitive business flows. So this is basically this was a new addition to the OWASP top 10 list. So I'll give you an example. So assuming we have a I assuming we have a limited edition of, let's see, what's the newest game on the market right now? Okay, let's use GTA 5. Let's go back 10 years and assume we're releasing GTA 5 again. So assuming we have a limited edition of Grand Theft Auto 5 on the market, and only 100 people should, we only have 100 copies of this game. So me as an attacker, maybe I want to buy these games and sell it at a higher price, because let's say this game is 10,000 shillings, for example. So I go and I write a script that allows me to buy these 100 games, assuming that maybe I'm not able to buy as many games as possible. So I buy these games from different IP addresses and using different IP addresses. So different IP addresses. So this API doesn't really know that it's the same person buying this application. So buying this particular game. So if I buy the game, and as an attacker, I can buy all the games, all the 100 of them, and then take them and then sell them for maybe 12,000 shillings or 15,000 shillings. So it's more of a business issue than an application issue, but it's still an issue either way. So yes, so that's unrestricted access to business flows. And then server-side request forgery, just like I explained earlier, the ability of you to make an application, the ability of you to make a purchase. The ability of you to make a request to another server from your own server. So yeah, that's basically server-side request forgery. So you can use an API to send a request to another instance. And then the next one is security misconfiguration. So security misconfiguration is a good case of security misconfigurations on APIs. Let's say I have an API key, and this particular API key should be restricted to maybe a particular machine or a particular service. So you might find that I have this API key that's exposed, and I'm able to take this particular API key and make requests to another endpoint that allows me to get sensitive data. So I'm able to get to use that particular API key that does not have that is not hardened to get requests to another instance. And then improper inventory management. So I'd like to give you a practical example on that as well. So if you try and sign in through Google on any machine, on any service that allows you to sign in using Google, if you look at the URL very well, you're going to see something written / and then v3. So API versioning is used to, maybe when I make an improvement on an API endpoint, let's say on back to my e-commerce application, if I make an API improvement that allows customers to maybe an API endpoint comes with more data because it's a compliance requirement or anything of that sort. But if it's a compliance requirement, it definitely be removing things, not adding things. So maybe I'm removing sensitive information that was passing through that particular API. So that means that I'll have to version the API again. So if I don't decommission the API endpoints that I was using, and an attacker tries to make a request to that old endpoints, then they're able to see information, they're able to fetch information, or they're able to fetch data that was not supposed to be fetched by uh, by 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 an actor at all. So when you come up with a new version, you should retire the old version. You should retire the old API endpoint, and because if you don't, then you're going to have cases of improper inventory management. And then unsafe consumption of APIs is basically uh, the ability to just misuse an API. Let's say if you're supposed to, this API allows you to maybe do this API endpoint can be able to should allow you to collect a certain amount of data from a database. You as an attacker, you take advantage of this API endpoint, and you're able to pull more data as compared to what you're supposed to be pulling from that particular endpoint. Therefore, you misuse this API endpoint. So, and then you have the next one, which is OWASP top 10 for mobile applications. I think I'll rush through this. Improper credential usage. So this is basically using credential things like keys and stuff like that. Hello, can you hear me? Hello.
Yes.
Yes,
Yeah,
yes,
yeah.
we
Can
can.
hear you.
Okay, so improper platform usage, not credential usage, sorry. Improper platform usage basically allows an attacker to use an application to misuse the platform mobile application. And then inadequate supply chain security. These are cases where you use back to our packages issue, where you're able to have different, we're able to use different packages, non-verified packages from sources that are not are not are not repeatable. So if you're using maybe a Google Maps package from, let's say, a guy called Prakash, for example, we all know a Google Maps package will come from Google and not Prakash. So that's a case of inadequate supply chain security. And then insecure authentication and authorization are cases of authentication flows, as I had explained on the OWASP top 10 for APIs. And then insecure input-output validation is basically passing user supply data that is unsanitized or not filtered, and which might lead to cross-site scripting attacks and SQL injection attacks and other injection attacks. And secure communication is using HTTPS, SSL, uh, not enforcing HTTP SSL, and not enforcing data encryption of data in transit. Inadequate privacy controls goes back to the story I was telling you guys about broken object level authorization. And then inadequate binary protection is the ability to reverse engineer an application and add malicious code to it and push the application back to maybe Play Store, for example. And then security misconfigurations is what I explained on the OWASP API top 10. And then insecure data storage are cases where if you're having an application that's running offline, you're able to able to see able to get this particular data that is being stored on this database, and able to interact with this data that is being stored offline if it's not encrypted. So data that is being stored, that is being persisted on a mobile phone, should be encrypted at rest. And then insufficient cryptography also goes back to what I was talking about on the web, using invalidated certificates, using weak hashes, and yes. So security testing. I'll talk about 3 security tests. So we have static application security testing. So this is basically looking at an application. This is basically running a scan on an application on your favorite version control platform, so GitHub. So you're able to review this scanner is able to review the application source code and get vulnerabilities just by looking, quote unquote, looking at the code base. And then dynamic application security testing is basically that now that we've seen that this application has vulnerabilities, has this and this vulnerabilities, uh, the dynamic scan basically comes to look at, uh, runs the application and confirms if these vulnerabilities actually exist. So, so for tooling, for static application security testing, you can use tools like Bandit if you're running a Python. If you're running a Django application, you can use a tool like Snyk. You can use CodeQL. You can use Veracode, and the examples go on and on and on. And then for dynamic application security testing, I think I've only used one tool that it's not there yet, but 2 tools. So you can use Babsuit, and you can use OWASP Zap for the same. And then penetration testing is basically simulating attacks to identify potential security issues. So, so the best methodology to use for applications, OWASP has different methodologies. So you have the web security testing guide for web applications and APIs, and then you have the mobile security testing guide for mobile applications. And then so security code review. So security code review is basically manually looking at code to discover possible vulnerabilities. So there are different approaches that can be taken when doing security code review. So there's a top to bottom approach. So the top to bottom approach basically looks at the application from a point of abstraction. So you can look at the overall architecture of the application, and then looking at the different modules, and then you boil down to the nitty-gritties of the application. And then the bottom to top approach is basically now looking at now you need to look at the specific implementation of the code. So that's why you look at the logic, the data types, the functions, your APIs, and so on and so forth, as you work upwards towards the places towards abstraction. And then you have the threat modeling approach. So you need to look at now this is where you look at maybe your OWASP top 10, and then you go and look at different. Now you go and review the application source code on based on these particular vulnerabilities. And then you have the risk-based approach. So this is where you look at risks that face this system. So this varies on a case-by-case basis, and then you're able to get potential risks on about this particular application. So I won't delve so much into this. You can go read this at your own time. I got this material from someone called Trevor Saudi. He's very vibrant in the Kenyan community, and he's done very extensive research on security code review. So you can go look at that particular article. I think Hope has access to these slides, so I'll paste it after my presentation, or she can as we're talking. And then so as I said, application security is a very small part of DevSecOps. So I'll give you a very hands-on look, a hands-on guide on how you can do static application security tests and dynamic application security tests, and just looking at secrets using a tool called Git Guardian. And then if time is on our side, we'll do code review. I don't think we'll be able to do code review, so I'll just take you through the static application security tests. So so we have this repository here. If you can't see it, please let me know.
We can see it.
Okay. Oh, okay. Are you able to see it now?
Yeah.
Okay. So, let me just paste the link here. This is a Django application that I forked from a certain instructor called a certain YouTube channel called Traversy Media, and I thought I could, and I wanted to learn Django. So I'm not able to see the chat. Hope, are you able to paste the link?
Yeah, is this in the slide?
Huh?
Is this link in the slide, or we'll share it separately?
No. Yes, it is now. It's on the slides now.
Okay, I'll post.
Okay, so we have what happens is let's rerun this. So so once we push our code to GitHub, you're able to run this particular workflow is triggered, and it basically looks at your code, and then gives you results based on based on it gives you results and uploads it as findings. So it's let's look for it now. Where is it? It should be. Just give me a moment. Okay, not able to find it, but okay, let's open our Snack page, and then we'll be able to see the results. Ideally, the results should show after the workflow executes. So, but I'm not able to look at to see it. So, in the interest of time, okay. So let's wait for it to load. So we can look at our code now. So you can see that we have a hard-coded secret here. So this is basically the secret key that is used in Django applications, and then we have the ability of performing a cross-site scripting attack. So this is basically a SAST scan. So if you don't manage to see what exactly is on GitHub, you can always come to your Snipe dashboard and you'll see the vulnerabilities that exist on your application. And then other things that are done in the Snipe in the scan for this application was scanning the container and looking at the packages that are there. So yeah, so we've seen these are the issues now affecting the different libraries that I've used. So because this is an application that was written some time back, so we need to update our Django version and other things. So the list goes on and on and on and on. So we have your SQL pass, your high level vulnerabilities, and so on and so forth. So you can have that as an example. And then for dust scans, so now this we can do a baseline scan. So I already ran the baseline scan before the meeting. So once the scan runs, it opens an issue on GitHub and then gives you the vulnerabilities that exist. So you can see now on this particular scan, you have absence of anti-CSRF tokens. This is a very basic scan, so the issues that you're going to see here are very trivial, and some of them are also some of these things are usually ignored in production. So yeah, I think the only thing that I'm seeing here that is very big is the absence of anti-CSRF tokens. Yeah, and then it gives you the links that it scanned to check for this particular vulnerability. So that's how you use OWASP. So this is usually triggered depending on how you've done your workflows.
Kiiru,
So
you're sharing the wrong screen. I think we're still on Sneak, and I think you were talking through Zap.
yes, I was talking to through Zap. Sorry. Are you able to see my screen now?
Are you able to repeat Zap?
Yes, I'm able to repeat Zap. So so what we have in Zap is basically we have a workflow here. It's a very basic scan. it looks at the vulnerabilities that exists on this application during runtime. So once the scan runs, it adds an issue on GitHub. So you have your report here, and so it shows the alerts that have been found. So you have different vulnerabilities at this point. So so you have your absence of CSRF tokens, and the CSP header is not set. Your headers for permission policy are not set, and then cases of disclosing of private IPs, because so it tells you where the issue and where exactly the issue was found. So this scan can be made better, because this is basically a baseline scan. It's very high level. So if you use ZAP in a better way, because of the interest of time, we really can't delve into that. This is what we have now. And then so that's dust. And then I don't think we have, I think we've gone beyond time for security code review. I thought we'd have the time to now fix a vulnerability on this, the cross-site scripting vulnerability on this application, but doesn't look like it's possible. So I think we'll close. We'll go to the next. We'll go to the next step, and look at your career prospects. So with application security, you can work in cybersecurity assurance. So basically looking at the application, just looking at the security of applications, looking at the security of different applications. And then you can work as an application security engineer, and you can work as a software security engineer. That's if you're transitioning from a software development background to an application security background. If you have knowledge in other fields beyond the penetration testing and the development and the deployment phase, so beyond the cloud security bit and the development bit, you can be able to work as a DevSecOps engineer, where you look at things beyond from a holistic approach. You can also work as a bug bounty hunter, and then you can also work as a penetration tester, specializing in web applications and mobile applications. So what we've done here is very high level. So if you want to learn more, you can visit Portswigger. Portswigger is the company that maintains Bapsuit. They have really awesome content on web security and API security. You can also look at the OWASP mobile application security testing guide. If you want to get into mobile security, you can also look at the mobile application security verification standard if you want to understand how to secure mobile applications. For APIs, the best books that I've read so far is Hacking APIs, a book by Corey J. Ball, and Black Hat GraphQL by a guy called Dolev Farhi and Nichols Alex, if I'm not wrong. And then for if you want to look at real world vulnerabilities and real world vulnerabilities that have been discovered by researchers from all over the world, you can always go to HackerOne. HackerOne have a page called Hacktivities, so you're able to see different vulnerabilities that have been reported and resolved, affecting the who's of Silicon Valley and different technology, your favorite applications from all over the world, as long as they have a bug bounty program on HackerOne. And then you have I find Twitter to be a very, very resourceful tool if you use it correctly. So you can, there are people like Hacklook, Cybermentor, I'm forgetting a guy called IPSEC, and so on and so forth. So you have all this I like to call them teachers on Twitter, and and they also have YouTube channels as well. So if you have time, you can go peruse through their YouTube and Twitter for very resourceful materials. And then you have Hack the Box for doing your boxes and learning as well. So yeah, I've 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 taken 7 minutes of your time, so I think I'm willing to take not I think I'm willing to take questions, and if there's something that you didn't understand, please feel free to ask uh, now, because I know there are some places I skimmed through in the interest of time.
So thank you, Kiiru. And for the first question with the hand up, I'll go to the one on the chat. So Daniel is asking, as an application security engineer, do you create websites that you perform security checks on? Did you have to learn web dev fundamentals and frameworks for the web? I think those are two different questions. So the first one is, do you create websites that you perform security checks on?
Not really. I have since pivoted from development, maybe 3 years ago, maybe 2-3 years ago. Yes, but I don't really develop websites anymore. So what I do is I work with different software developers. I work with software developers to improve the security on their applications at this point.
Okay.
What was the second question?
Did you have to learn web dev fundamentals and frameworks for the web?
Yes, I did. I did, and to some extent, I still am. You really can't run away from programming when you're doing application security. So yeah, at some point I did Flutter for mobile applications, and a very long time ago, I learned Python and Django, but I did Django because Django is a framework. So yes, I did Flutter for mobile applications, and I did Django for web applications, and of course PHP. So that I can be able to understand how the web works and mobile applications. Whether I use them nowadays, I don't really. No, that's not a question that you asked, but I don't really use them nowadays. Maybe Python for scripting and doing very quick hacks, but not. I don't actively develop. Yeah, that's the next question.
So we have a hand from Mordecai. Mordecai, you can go ahead.
Hi guys, I do hope I'm audible enough.
Pardon?
You're audible.
I do hope I'm audible enough.
Yes,
Yes, you are.
Yeah, so first of all, I'd like to say thank you. Wow, it's quite impressive, especially when it comes to things like even the references, because I'll have to hand it to you. I've been looking at things like APIs, especially when you touched on this book by Corey Jobo, the hacking APIs. It's quite a good book, and I love the fact that you referenced it. So kudos on your end. Now I have a few questions, and particularly on code review, because you've actually brought up something. I actually have a report on I like code review of it was more or less kind of an assignment, kind of, but it was going to be an implementation of like an app, and it was written in Flask. So as I was writing my report, I encountered some hurdles along the way, and the first one was categorization of vulnerabilities. Now, when you look at how we look at the OWASP categorization of vulnerabilities with reference to APIs, and then we have the common, CWE or like CVE references when it comes to vulnerabilities. So, for example, the one that you mentioned previously, the broken object level authorization. isn't that quite similar to something like indirect object reference? But now in this case, you're actually dealing with the APIs to some degree. So when it comes to real world, let's say pen testing, how do you handle that? Like, do you place them all in one box, or do you use either one and explain effectively what it is? So do you say, like, for example, this is IDOR and this API did blah, blah, blah. It's accessing particular objects that it's not supposed to reference, or do you just say that it's broken object level authorization, or both? So that's the first question. Secondly,
I think you
with
can just give
regards
it a
to,
pause. He answers that
okay,
first, and then you can go to your second
okay,
question.
okay, cool.
Okay, so now now that's a very good question, but I tend to look at it as most of the time I tend to look at it as from a scope perspective. So let's say I'm doing a pen test and it's focusing on API endpoints. So if I find a broken object level authorization, you're right, it's the same thing as an IDOR. So so if I have that, what I'd report it as broken object level authorization, because we're looking at I'm looking at the API scope I'm looking at it from an API point of view. But if I was looking at it from a web point of view, from now the greater web application point of view, and including and excluding APIs, I do I'd categorize it I'd categorize it as an IDOR. So for me, it's usually I'd look at it from a semantics issue and a scope issue.
Nice, nice, nice. So I can move to the next question now.
Yeah.
Okay, so the next one is with regards to some of the things that you actually touched on, and I'll also reference my report, or should I call it so? So this is with regards to, you touched on something regarding CSRF tokens and hard-coded secrets. So let's say from a pen tester's view, if you are to do something like a code review, so you basically do have a source code, you're supposed to test out everything. And in certain scenarios, okay, so the first one is you have something like a CSRF token. So in my case, I found that the application was able to, okay, for each and every session, the CSRF token was like, you find that there's a CSRF token that was used, and it had to use a secret, or rather a hard-coded secret that was within the application configuration files, and this was a Flask application. So you had a CSRF token and you have a username, and this was used to generate, I'd say, a cookie session that you would use to log in. Now, depending on the username that you actually used and the CSRF token that was generated, I'd say this is a good security feature. Now, the problem that comes in was it was one CSRF token that was generated and it was the same. So let's say you have user one named Bob and you have the second user, say, named Joy. If you had one specific CSRF token, it was the same and it allowed you to log in as any of these users as long as you had this CSRF token for that specific session. Now, I wrote in the recommendations randomization of CSRF tokens, but now the question comes in, especially for most applications. So for example, in this case, I knew, for example, I mean, it's common sense. You should be able to randomize the CSRF token, but from a practical perspective, I'm very curious as to how that's implemented. Because, okay, in this particular situation, you would need the secret key, but the hard-coded secret, which is the next question that I actually do have for you with regards to environment variables, would have to be used. But now, how do you randomize CSRF tokens specifically, like when it comes to actual implementation with applications?
Okay. I've actually, that's a very good question. I haven't seen anyone use more than one randomizing CSRF tokens. It's bad practice, I agree, but ideally you can use these tokens need to be randomized, so you can randomize it based on using a random number generator. Uh, this is available. This is something that you can do on code. It's something that's very practical. It's something that can be done. So you can do. You can have your. You can have your. You can have a. You can have a. You can have a function or something of the sort that basically generates CSRF tokens based on random bytes. Yeah. So that's one way you can do it. It's not what is done using one particular token is not good practice, as you have said. It's actually very unsustainable in the long run.
Yeah. Thank you. Now,
Yeah.
I'm really sorry. I really hope I'm not taking so much time. But let me just do the last two, but I'll put them in. I'll try to summarize them the best way possible. So mine is with regards to, so like we've talked about the CSRF tokens, but then I understand the element of it not being the implementation of not randomizing it as such. And part of that comes to the aspect of, for you to generate, let's say, like a session key, in some situations you'd need something like a hard-coded secret, or like should I say a secret key for you to be able to implement that. Now, in this particular situation, for example, in my situation, I found that a secret key was actually written explicitly within an application. One of my other recommendations was the use of environment variables. Now, when it comes to, okay, from your perspective, is it advisable to use environment variables, or is there any other way to like safely implement, let's say, the use of, let's say, secret keys in a way that does not expose it to attackers? And lastly, just resources in terms of where to pretty much practice all this. Because for me, I'd say I do a lot of freelancing from work that I get, or let's say like I'm doing assignments, or someone like word of referral. So what are some of the platforms that you can actually have access to, where you have this? Because from my understanding, most of what I understood greatly about web applications was doing through a lot of source code review. So you get to understand how developers implement something in a very unsafe way. Then you can now see ways in which you can try and make sure that it's implemented safely. And that puts you in a position where like you're in deep, but then you have to find a solution yourself. So I think that's all. Thank you.
Okay. So actually, you've just reminded me. I was having a conversation with someone a few weeks ago about using environment variables and using in secrets management. So so lately I've been looking at you have very many options, just depends with what you're looking for. So for managing this particular secrets, it also boils down to how much uh what exactly are you looking for? Are you looking for convenience? Are you looking for scalability? Are you looking for security? Because some in as much as you have a secret management tool in place, it might not be the best way possible. So you might choose to maybe run a tool like Vault, and you don't keep your secrets on and call them as environment variables. So you have a separate instance or a separate server running Vault, and you call these secrets using an API. And because you need a token, so you can use something like you can store the token on maybe a tool like GitHub Secrets, or you can store it on something like GitHub Secrets, where every request that is made to the API uses this particular token, and then you can add this particular secret to the application maybe during the CI process. So you can add it as an argument into the Docker image, then call it from, and then use it as a, it still lands as an environment variable. You really can't get rid of the environment variables, but this makes it's actually, it's a step forward, because now you just have one secret to manage as an environment variable. And if this secret gets compromised in one way or another, you can always come back. You can always revoke it and put another one into production as fast as possible. So yeah, you have tools like you have GitHub secrets. You have actually, in this particular repository, I've used GitHub secrets for my secret management. In production applications, you can have something like HashiCorp Vault. You can have if you're running in a Kubernetes environment, you can have something like Kubernetes secrets. If you're running on something like, if you're running on a Docker Swarm, which is the Docker's version of Kubernetes, you have you can use Docker secrets and so on and so forth. You can use something called Conjure. Yeah, the examples go on and on and on. So environment variables are a good step, are a step in the right direction, but they're not there. They're not, I think they're way better tools to use for secrets management, especially at scale. I don't know if I've answered your question.
Yeah, you have.
Yeah.
Okay. So we'll take a question from Jao, and then I think there was Mr. Robot or something like this, right? So Jao, you can go ahead.
Quick questions. I believe they won't take as much time. So one, as a person transitioning from backend development, the way you did your transitioning into AppSec, which certification would you advise a person to go for, given that in the industry at the moment, most people require certification for cybersecurity as a stepping stone, just to get that interview, that job. Secondly, this is a scenario that has played out severally in maybe some of the few jobs that I've done. You have an API endpoint which limiting, and then maybe using Babsuit in this case, and then you discover that all these requests are actually going through without, they're not being limited at all. There's no timeout session, there's no maybe you understand, there's no rate limiting. But then when you raise the issue, the developers will tell you that that is in UAT or that is in testing phase. But in production, because they have a firewall, and maybe yeah, because there's a firewall, then that is not an issue. So from your expert point, do you think this is an issue that needs to be addressed? Do you think rate limiting should be allowed, should be fixed at the UAT level, or the firewall is enough to cater for that when it goes to production, and maybe an API gateway in production? That's all.
Okay, so I'll answer the easy question first, and then the hard question second. So the easy question is the rate limiting application, the rate limiting question, and whether we should have it on whether we should have it on test environments. Yeah, and test and staging environments. Being a huge fan of defense in depth, I believe we should have security the word go. So if you're having things critical, you should have also on the application level, because I've also witnessed firsthand on how bad cases of no rate limiting can be, because you might look at it as such a very small, a very trivial matter, but I know applications and services that have not, that don't have rate limiting, and they're struggling with latency issues because of resources being consumed by by different endpoints. So I believe we should have rate limiting on all environments, and then so and then use of a firewall is also good, but use of a firewall is good, but again, defense in depth. In as much as you have a firewall, I believe that you should also have a secondary mission on the application level, because the firewall doesn't. Yes, the firewall is also on an application level, but I believe that we should develop a defense in depth strategy. It's an ideas issue. It's actually an issue of different opinions and different approaches towards security, but ideally that's what I choose. Certifications. Wow. Uh, I have a really strong opinion about certifications because I've met some really talented people and very skilled people who don't really possess any certifications, and sometimes I tend to think it's really unfair for the job market to judge people based on the certifications they have. So I really wouldn't advise someone who's coming in from from whatever background to start looking at certifications from the get-go. I believe certifications should be gotten maybe after you've gotten some experience. And on what certification you can go for, there are very many certifications. Uh, if you're looking for a certification that will get you a job, no, that might put me in hot water. Else you can give me a chat and then I'll give you an answer for that. And but I've seen some really good certification, like Portuguese certification is very good, very practical, very hands-on. So I'd recommend that any day to anyone who wants to get a certification in application security. So yeah, so yes, don't take away. Don't be in a hurry to go look for certifications. Try as much as possible to get the knowledge, because once you have the knowledge, nothing can stop you. You can, as long as you have the money, the finances, you can always take these certifications any day, anytime. You're going to pass them. So look for knowledge first. Is there anyone else who has a question?
Mr. Robot, I don't know if that's this is actually, but there's a hand up from him or her. Okay, so if you're not on the call, we can have Daniel as the last question. Daniel, go ahead.
Hi. Thank you, Kiiru, for the presentation. I'm not in application security, so I won't ask one in that area, but maybe just in a general impression. How much do you use AI, and how is AI transforming your space? And if you have some information on the infrastructure security, would you also maybe share with us, like from the work experience, like how is AI coming in, or like how do you interrelate with guys who do infrastructure security for applications and so on and so forth?
Okay. I What do you mean by infrastructure security?
Oh, sorry. Just like the virtualized environment that you guys work with, like everything from the network to the to the servers to the virtualized environment that you guys are working with. I think we work securing that in terms of infrastructure engineers, administrators, sort of. So, like, I'm just trying to ask, how do you interact with those guys who fix and who build the environments for you?
Okay. Good. So, I'll answer your question I'll answer the AI question. So, how has AI influenced my field? So, I'll speak about it from a personal point of view and how I have used AI in application security. I just hope my employer is not on this call, but AI has really helped in cases where I'm doing things like code review. That way, sometimes if I have issues pertaining to maybe a particular code block or something of the sort, I'm able to maybe run it through my favorite GPT, and I'm able to run it maybe through ChatGPT, and so, sometimes it gives me wrong vulnerability, wrong issues, but most of the time, more often than not, it's correct. So yeah, so there are cases where I do that. So for me, it has helped me in cases of code review, and also doing doing some automations here and there. Nowadays, I don't have to really think much if I'm doing a script to do something for me. So I'm able to do maybe get a baseline from ChatGPT, and then move on from there and customize it and tune it to meet my needs. Tune that particular script to meet my needs. So basically, that's how AI has helped me in my field. And then for securing infrastructure, especially applications that run, because at the end of the day, an application has to sit on a server one way or another. So there are very many tools out there that can assist you. There are very many materials and very many manuals. So the CIS benchmark is a good place to start. If you're securing information, if you're securing infrastructure, sorry, and then and if you things like for technologies like Kubernetes, Docker, Consul, and whatnot, their documentations are very. They have a section where they cover security and they cover it deeply. So there are different ways of hardening these particular technologies from a security point of view. So yeah, you're able to you can always look at the documentation, and you'll always find guidelines on how to go around securing a certain piece of technology that is used as part of your infrastructure. Yeah. And I don't know if I ever answered your question.
Very much so, very much so. I don't know if you've encountered Gen AI or its usage yet, or is it still new? Do you know anything much about that, of it coming into application security, Gen AI?
No.
Oh, okay.
No, I have not.
Don't worry, I think it's pretty new. Even we are just trying to figure it out right now. So yeah, thanks.
Okay.
Yeah, so I think that brings us to the end of our session. Kiiru, just from the chat, if you could kindly attach an email or how you'd like to be reached by the students on the slide, we'd really appreciate that. And then also the link to the practical demo you did. I don't think that was attached either.
Okay.
So,
Oh, here they are. I've been looking for the charts for a very long time. I really hope I clicked on the right button.
So just attach that to your slides, and then I'll share the slide. So we've gone above and beyond time. So if there are any questions, any remaining questions, the link or a way to contact Kiiru will be attached on the slides. Then just back to you, Kiiru. Were you done with the presentation before I close the session?
Pardon?
Sorry, back to you. Were you done with your presentation before I close the session?
Yes, I was done. Thank you very much for your time, and thank you so much for staying way past time. I'm seeing that we are over 100. So thank you very much for your time. I hope you learned something. And yeah, I hope you people get into application security because it's a very awesome field. Yeah.
Okay. So thank you so much for your time, Kiiru. Thank you for delving into application security. We can all say that it's been quite engaging and very relevant. So there's a lot that has been shared. There's a lot of resources, a lot of knowledge, a lot of what else? Different ways to get into this. So I hope it sparked an interest. I also hope the minute I share the slides, you can just sit down, have some quiet time, and go through the resources shared, and the slides themselves, and see how this can be relevant for you. So thank you again, Kiru, for coming on board and sharing all this on application security. Thank you for also your time and even having the patience to go beyond time and make sure most of us are completely satisfied with what has been shared. And thank you for answering the question. For the team on board, thank you so much for joining the session. Thank you for staying this far. Thank you for engaging, and I hope it builds you somehow. So thank you, everyone. Have a good night and see you next time.
Thank you. Thank you.
Thank you. Thank you very much.